I think we're going to get started here. They've told me I still get 25 minutes, which is great, because I usually do this presentation over 60 to 90 minutes, and we code and refactor a bunch of code. So we're gonna have not a whole lot of fingers on the keyboard to refactor code, but we're gonna look at some before and after as we go. So this talk is JavaScript performance. We could call it for absolute beginners. So who am I? I'm a senior developer for the state of Utah for the Department of Technology Services. I've been there for 22 years. Sitting at the speaker dinner last night, they asked whether this was a great company to work for, and I said, well, the best thing about it is that in 8 years, they're going to pay me 60% of my salary whether I show up for work or not. So thank you for the pension to the great state of Utah. It's actually, I work on a fantastic team. I work on a team of senior developers. We are called the Core Services Team. And we do a lot of our own little projects, about 40 websites for the state of Utah. In addition, we get farmed out to other groups to help them out, because supposedly they think we know what we're talking about. I think by the time we get to the end of the talk, my goal is to not make it obvious that I don't know what I'm talking about. That's my goal today. So there's some contact information for me, and the GitHub address will come up a couple of times. There's sample code for this whole workshop on GitHub. Who are you? So I've made some assumptions based on the tracks. This is the only session that was targeted at only beginner developers. Everything else said it was at least beginner or intermediate and advanced, and yet a whole bunch of people voted for it because that's why they invited me to come here. So my assumption is that you consider yourself a JavaScript beginner. Now that doesn't necessarily mean you're a programming beginner. I first started programming on a TI 99 4A. Did anybody in the room have a TI 99 4A? How about an app? Did you buy it on eBay? You don't look old enough to have a TI 99 4A. How about an Apple II? So I programmed on an Apple II in middle school. My first personal computer was a Sinclair Z81 that I built in a kit and put together. My first computer when I got to college was a 286. I upgraded it to 2 megs of RAM, and it had a 40 meg hard drive, and it was smoking fast. So we're going to talk a little bit about code performance, primarily because I'm one of these old school guys, like they talked about in the keynote. I've been writing code for long enough that the performance of the code really did make a difference. We're going to talk a little bit about the situations where it does make a difference or doesn't. I assume that you're here because you're new to JavaScript or new to programming. You may be an excellent C# developer or Java developer or Haskell or Ruby, but you're here to look at some things that are specific to JavaScript. Maybe you're a designer who wants to be a developer. Where are we going to go? Well, we're going to talk a little bit about the pain of trying to measure performance when you're dealing with web apps and JavaScript apps. It's way different than if you're dealing with languages that get compiled or compiled to bytecode like Java or C#. We're going to talk a little bit about some loop optimization techniques that I think are common across most programming languages. We'll talk a little bit about array functionality and learning what's built into the language or framework that you're dealing with. And then we're going to talk about DOM manipulation, which is specific to the web, and probably the place where, as I build apps myself, I make the biggest mistakes. And then, depending on what our time is, we'll look at performance measurement again and some ways to do some generic performance testing. Some places that we're not going. We're not going to talk about big O notation. If you know about big O notation, you can get to me after the session and explain it to me, because I don't have a computer science degree. I have a master's degree in economics. I get to use all the math and statistics that you said you would never ever use to help people write economic forecasting software. We are not going to talk about algorithmic theory. We're not going to talk about whether a bubble sort is better than any other sort. And we're not going to talk really about the specifics of any JavaScript framework. I'm not going to dive into how you can optimize Angular or React, or whether you should use Knockdown, or not Knockdown, what's the one with the K? I forget. Knockout, that's it. And we're not going to talk really about any differences between ES5 and ES6, except one. And that one is going to be just my first example, just because it ends up being a good example. So I'm going to leave this slide up for just a minute if you want to take a picture or if you want to just type it out. The entire set of code, the workshop for this code, is available at this GitHub. So while you do that, I'm going to tell you a little bit of a story about one of my apps. So one of my first apps I built in the late 90s was designed to store wage data and let people look up the average wage for a particular occupation. It was an Access database backend with a Visual Basic front end. And this was production code. It got bundled up with an installer, sent out to about 700 people across the country who their job was to look up wages. The web happened. We converted it to a web app with ASP, classic ASP, with a little VB script on the front when you could still do that, and SQL Server on the back end. And then in the early 2000s, we converted it to C#, again, JavaScript in the front, and it now has, it's not really seen a major update since 2005. Been running since 2005. It's not responsive, it's not pretty, it doesn't use Twitter Bootstrap, but it works. It processes one, at peak time, it processes 2 wage searches every second across the country, which, you know, compared to Google or somebody's not a whole lot, but compared to, you know, your little shopping app or something, it's pretty significant. The interesting thing about this, to talk about the performance, is this app stores 4 levels of wages hourly, and then it converts them to annual wages. And in the first version of the app, we would take that data from the database and pass it from the database to the middle tier all the way to the client in JavaScript, and then we would do the multiplication 4 times to make an hourly wage also show up as an annual wage. Then in the next version, we said, well, that seems kind of dumb. We're passing all this data all the way across and then doing the multiplication on the front. Why don't we just do the multiplication in the middle tier? And that's where it stayed. And not once did anybody say, you know, we only update this data once a year. It's got 80 million rows of data. Why don't we create a view in the database where we've already multiplied the data that one time when we did the update, and then we never have to do the multiplication again for a year. So I tell you that story because of this. We're going to look at code. We're going to look at basically stuff that would either be in the client or in your middle tier if you're doing Node.js. When you're dealing with performance, there's a lot of different places that could be the slow thing. The slowest thing on your app may, in fact, be your network connection. The slowest thing in your app may be downloading all the libraries that you need, particularly if you've included jQuery for the sole purpose of doing a selector, which I've seen. How many people have gotten the conference schedule site for this conference to work on their phone? I can't get it to load on my phone. Now I'm using an old phone. Sometimes your big performance problem may be the fact that your target audience is grandma. And grandma's using an iPad 2 or an iPhone 1 or a first version Kindle. And she's not running the fastest JavaScript engine. So be aware that there's trade-offs for performance at each level. So there we got resources, go to the back. So let's take a look at some code. and some examples. So the entire code base is set up to be run as basically katas, except for the first section and the fifth section. So for an intro, let's take a look at this example with let versus var. So in ES6, there's this new idea you can do let, and it changes the scope of your variable, all right? And so this is some sample code. I don't necessarily want to go through all of the code, but just to show you, we have a section here where we're going to pass in a function, and we're going to run it a whole bunch of times. We're going to calculate how long it took, the average time it took, and the number of repetitions we did, and we're going to pass that back as an array so we can write it out. And then we've basically set up a whole bunch of tests. We've got let inside an if. We've got var inside an if. Now we've got let inside a function, but outside the if. And var the same way. And we have some global variables set up. So we're going to run this code and see what happens. And you can see it's spinning up at the top there, spins for a second. So this is to talk about, again, your target that you're looking at. We just ran this in Firefox, and let inside the if at if scope was very, very fast. But var inside if scope was pretty fast too. In fact, whether it's inside if scope or function scope, really not a whole lot of difference in Firefox. If you put it at global scope, though, that's a big difference. Now, it may not be a big difference for your app because we're talking about the ability to do, hundreds of millions a second. But if you're Google, that makes a difference. Let's take a look at that in Chrome. So we'll load this same page in Chrome, and we'll let that run for a second. We'll load the same page in Edge. Let's go back to Chrome. So Chrome, you'll notice whether or not the let was inside or outside the if is a whole order of magnitude different. Then again, at function scope and at global scope, it's almost identical. So completely different performance profile from what Firefox gave us. If we look at, that was in Chrome. If we look at Edge, Edge doesn't particularly care where you put the variable. You get essentially identical performance whether you use let or var and wherever it's declared. So two purposes for this. One, be aware of the engine, what your target is, and then you have to figure out the trade-offs. Where can I be slow? Where do I have to be fast? The other thing to show is you're going to get differences across all of these engines. All right. Let's do. Let me close these. We'll do one more. We'll do one more example to transition into some of our more detailed code. So this is pretty common code. My wife's a teacher, and she has to calculate grades all the time. So this is an example of calculate grades. This is exactly how I ever first wrote how to calculate grades. I got my array of grades up here, and I write a little function that I can pass in the array and the index, and then I search through and say, well, if my grade is above 90, then I have an A. If my grade's above 80, I've got a B. Just a nested if. Now, I'm perfectly aware we could use a switch if the language works there. There's other language constructs we could use. But this is to show two examples. Here we're going to say, I'm going to search each time I look for that score, I'm going to search the array, versus the second one, we're going to cache the score once in a variable up at the top. And then we'll use that cached value to compare in our if. So we'll run the cache test, And you'll notice if we have to search for the array, if we have to search the array for that index each time, we are fully 4 times slower than if we cache the value outside of the if. And we only have to traverse the array once. Totally makes sense when we look at the code. When we look at the code, I've got 4 traversals of an object in this function. 4 traversals. In this one, I only have to traverse the code once. I only have to traverse that object once. So it makes sense that in this case, we would have faster code. I do, however, have to take a little bit of a penalty because I have to spin up a new variable to store that cached value. So it's never going to be a pure trade-off. For each technique that you use, you're gonna gain on one side, but maybe take a penalty some other place. So again, this is set up so that you could do these as a code kata if you're an experienced developer or you've got kids that want to learn how to develop. 2, 3, and 4 are set up as a step-by-step project with before and after code. This is what we're trying to accomplish in those codes. We're going to build a list of employees, all right? We've got a fake company. We're going to dump a current directory of employees onto a page. So let me show you the structure of the project, and then we'll work through the code a little bit more. We've got a very simple index page. We've got a task that we want to accomplish. We've got some elements for some output. In script, we have company details, which is a JSON document assigned to a variable. This is so we can simulate you've done an API call to get some JSON back. And then we've got our app. And so in our app here, to begin with, we have a list to store the employees. We have a function call to fill the employee list, and then we're going to dump some information to the page. We have fill employee list is where all the good stuff is. We'll come back to that. At the bottom, we have basically a simple object constructor. For fill employee list, we're going to loop through that big nested JSON DOM, or JSON object. Now, if you think back to our cached example, you can see where our pain is going to be. If I've got 3 divisions, and then I've got employees under each division, and I want to flatten my list, so it's division, employee, name, and their contact information, I'm going to do that in a loop to begin with. And I'm going to say, well, I've got 3, I'm going to loop through my divisions, then I'm going to loop through my employees, and then I'm going to loop through each employee and push their name into my constructor that then gets appended to my list. So each time we do that, we've got 3 steps to get the division name, 4 steps to get the email, 5 steps to get the last name, 5 steps to get the first name, and then we've got multiplicative steps because we've got nested loops. I didn't calculate for the nested loops. Just inside the constructor, we have 3,800 steps that we go through to push our developers, to get our employees in our list. How can we make that better? Well, we can do the same technique we did with our grades. We can take data that doesn't change inside the loop and cache that data. Elevate that data up the top. So we can cache the division list. Inside the division list, we cache the division name and the employee list. Inside the employee list, we cache the current employee, we cache the name. And that gives us just inside that inner loop, 2, 2, 2, 1, 7 times 225. We've cut our number of steps in half inside that loop. Now, does that matter if you're only doing 200 employees? Maybe not. Does it matter if you're doing 20 million employees? It probably makes a huge difference if you're doing 20 million employees, okay? The next step is to look at filters. So again, we have before and after in filters. And our task, I'll show you the task, is to take our list, and at this point we've got 225 employees. We want to filter the list. We want to show only active employees and sort by the last name in divisions. And for these first couple of sections, if you run through this, you're only going to see information in the debugger, but we don't have time to pause and hit the debugger here. But let's look at the code. So if I'm normally going to sort my list, by default, I got to get to before. By default, I'm going to do that in a list, and I'm going to do employee is active in the list inside where I'm pushing the employee into my big storage list. I've got a little note there. Don't be a noob and use equals true. How many of you do that all the time on accident? I do it all the time. I've got a property that's true, and I set the test for true instead of just using is active. So we push all the employees sorting by if they're true, but now we've got a little different problem. How do we sort them alphabetically by name within the division? Well, we could do that down here now that we only have active employees, but if we've got to write that in our own if or our own loop and our own sort, that's complicated. So we can use the built-in filters. Oh, I skipped. We can use the built-in filters that are built into JavaScript. We can filter on. We can take our first document and filter on, are they all active, and return that. And then we can filter on and then we can sort using the built-in function. Now, one thing to be aware, here you've got a trade-off. In the tests that I ran, doing the filter with an if was nearly always faster than doing the filter using the built-in array functions. Nearly always. And that's because the filter has to handle a lot more generic cases that I don't have to handle just in my if. But the trade-off, if you stay for the next session, is I've got far more readable code. I've got code that I don't have to manage because I didn't write it. I didn't write the filter. I didn't write the sort. And that's going to be easier on my life later. Finally, the crux of this, and I'm looking for my room host. I haven't seen a 5 minutes. Do we know how much time I've got left? I have 1 minute. DOM manipulations. Whew. All right, so let's do DOM manipulation. The biggest thing to remember with DOM manipulation is don't hit the DOM over and over and over again. So in this case, in my app.js, I've got write to a page, and for each employee, I append an item for each employee. And every time I do that, for all 208 employees, I'm forcing a reflow of the document. It's going to devastate the performance of my application on the website. So how do we get away from that? We get away from that by using a document fragment. So I'll show you this up here. So the key difference right here is I'm going to create an in-memory document fragment. And to that fragment, I'm going to append each list. That doesn't do my DOM at all. And then I'm going to append that fragment all at once. I get one single reflow. So take a chance if you can. These are just three options. Weigh the trade-offs between your different options. Every option is going to have a performance trade-off. And I hope you can leave us some feedback. If you have questions, you can contact me. Again, that's the GitHub for downloading the code, and I appreciate you coming and listening to the conference. Thanks.